Hello to all my wonderful champions, class 10th students. So my dear champions, I welcome you everyone on your favorite channel Deeksha Vedantu, and my dear all champions, you all can see on screen, I have come up with one short video. Entire polynomial chapter number 2 will be completing here in this single video, my dear champion. Yes, so your each and every your single doubts will be cleared. So let me tell you honestly, I'm going to give you one short video. I will not be directly jumping to the questions. I will be teaching you first basic concepts, definition of polynomial, types of polynomial, properties of the polynomial, graphical representation, and everything will be discussed. Then we'll be going towards the questions. My dear champion, this is the principle, this is the rule of mathematics when you are starting any new chapter. So don't try to direct jump to questions. Make sure to understand the concepts. Make sure to understand the formula, how to use, when to use. Make sure to go to the basics. Once your basics will be clear, your concept is clear, my dear champion, no one can beat you to solve the questions. Even lengthy, hard questions will be nothing for you. Right? So understanding the basic is very important. Understanding the concepts that is going to be used in future is very important. So my dear champion, let's watch this video. Entire polynomial I am going to finish here in this single video, and I'll be giving you theoretical portion, overview, concepts of the polynomial. So simply I'm going to teach you from basics to advance. So let's start this video, one short video, without wasting a moment. So the first question comes up in mind in most of the student, sir, what is the definition of polynomial? What is polynomial? How we can define polynomial? So before moving to any bookish language, any standard formula, let me give you very short overview of polynomial, what exactly the polynomial is, how you guys can define polynomial in very simple words. So my dear champion, listen here. If we talk about here, there are two kinds of things present in mathematics. If we know about variable, do you know about variables? So basically variables are those terms whose values keep changes. I mean, sometimes the variable comes up x is equal to 1, sometime x may be equal to 3, sometime x comes in negative form, sometime x comes 0. So basically variables are those things, those terms whose values are not fixed. The values will keep changing. So the variables are represented as x, y, or anything. We can also use z also. So x, y, z, these are variables. Why variables? Because their values are keep changing. Their values are not fixed. Sometime y appears 2, sometime y appears 0, sometime y may be -3, whatever. So these are called variable. Okay, now the second thing comes up, my dear champion, is constant. Constants. So constants are those terms, constant are those things whose values are fixed. The constant will never change. The constant means constant, fixed value. If I ask you the length of this smart board, the breadth of this smart board, I mean the dimension of the smart board, length cross breadth. So the length and breadth of this smart board will remain always fixed. It will not be changing at all. The length and breadth of this smart board will be fixed always. So the length and breadth are constant. So something which is fixed, which will not be changing in future, right? With passing of the time, that will not be changing, that is called constant. So any number, any mathematical value, if I write here 2, 3, -6, these are called constant. Without any doing mathematical operation to this number, if we are adding 2 plus 2, then only result will be 4. I mean, by doing the mathematical interpretation, the result will be some new number. But if you're not adding anything, if you're not multiplying anything, if you're not subtracting anything from this number will remain as it is in its original format. So 2, 3, -6, 0, -5, whatever, the numbers are constant and these are the variable. But when we combine variable with constant in systematic order, systematic manner, and this is the system here. Can you see the system? So if you arrange, these are A1, A0, A2, A3, An, these are the constant values. It may be -3, -2, 3, 4, whatever. And x is basically representing here the variable. So when we combined variable with constant in systematic order, not in random format, systematic order I am telling you guys. I am repeating again and again, systematic order. So when we combine variable with constant in systematic manner, the systematic format which comes which appears is called polynomial, and that is the format for polynomial. So we can write a polynomial fx, and I'm taking a constant here, let's say 2, and I'm taking one variable. You can take any variable, x, either x, y or z, you can take anything. So I'm choosing here x, so 2x plus, now I'm taking one more variable 4 and x square, 2x plus 4x square. So this will be a polynomial, because this is going under this format. Can you see here, a1x and 4x square, this. So combining these two will form a polynomial. So polynomial is an algebraic expression px of the form px is representing polynomial, p for polynomial, and x is in the form of x. You can also write py. fx is not fixed. You can write polynomial in the terms of y also. You can write the polynomial in terms of z also. You can write the polynomial in terms of t also. You can write any polynomial. Variable, you can choose any variable, x, y, z, ab, whatever. Are you getting my point? So polynomial is basically an algebraic expression px of the form in this format. This is the standard format for polynomial. Make sure. You know, the power of the variable is increasing order. So here no variable is there, it means the power of variable will become 0. And now the next power of variable is 1. Now next power of variable is 2. Now next power of variable is 3. And at the end the power may be n also, if we are writing n number of terms there. So this is all about polynomial. I hope you have understood it. So what will be the definition of polynomial? The systematic arrangement, the systematic format of combination of variable and constant. The systematic formation, the systematic arrangement of variable and constant will give you a format, and that format is called polynomial. And this is the system here for polynomial. Moving to next. Now the next question comes up. How many types of polynomials are there? You have understood the polynomial. So let me write it again, the standard format. Standard format of polynomial. Standard form. So the standard form of polynomial is basically a0 when the variable power of variable will be 0. So we can also ignore x to power 0. We don't need to write x to power 0. If you want to write x to power 0, you can show. Otherwise, if you don't want to write the x to power 0, you can ignore also. Okay, the next will be a1, and the power will be increasing by 1. You don't need to write 1 also. If there is nothing, means 1 is there. Okay, so I'm writing here for your clarity, for your visibility. Now a2 x to power 2 plus a3 x to power 3, and so on. If the number of terms are n here, so the last will be an, and x to power, the power will become n. So this is the standard format of polynomial. Now moving to next, types of polynomial. Types of polynomials. So my dear champions, my dear class 10 students, there are 3 types of polynomials. How many types? 3 types at your level, at 10 standard level. Otherwise, biquadratic polynomial is also there when the degree is 4, when the degree is 5. You will be studying all those rest polynomial in the higher classes. But at 10th level, in your 10th standard, you will be studying here 2 polynomial, linear polynomial and quadratic. Right, cubic is also excluded. So cubic is, earlier cubic was there 2-3 years back in the old book. After the modification in recent past 2 years, the cubic polynomial is also reduced from the syllabus. So we will be studying here only 2 polynomials. But I am writing here all 3 polynomials for your knowledge. So the first polynomial is called, my dear champion, linear polynomials. Linear polynomials. Linear polynomial. The second comes up as quadratic polynomial. Quadratic polynomial. Quadratic polynomial. And the third polynomial is cubic polynomial. Now, what are the differences between all these 3 polynomials? This is cubic polynomial. My dear champion, focus here. The linear polynomial is that polynomial in which degree is 1. Degree is 1. Now you might be confused. You might get confused. So what is degree here? What is called degree? So my dear champion, degree is nothing. Degree is, it is the highest power. It is the highest power of the variable. Of the variable in an algebraic expression. In any algebraic expression, the highest power of variable is called its degree. The highest power of the expression of the variable in that particular algebraic expression is called degree. So degree, when the degree is 1, this is called linear polynomial. Why linear polynomial? Let me show you one polynomial. So px is a polynomial in this format. Can you see here? 2x plus 3. Now if I ask you, champion, in this polynomial, where is variable? So x will be the variable. And what is the power of x? The power of x is 1. If there is nothing, means there is 1. Apart from this x, other than this x, there will be no any other x. There is no any other x. Only that x is present. So that will be the deciding factor of the nature of the polynomial. And the power is 1. Here the power is 1. Here the power is 1, so that will be the degree, the highest power of the variable, and only one variable is present there. So if only one variable is present there and the power is 1, so that polynomial is called as linear polynomial. I hope this is clear to you all. Now moving to next, what is called quadratic polynomial. So quadratic polynomial are those polynomial whose degree is 2. Again degree is 2. Degree is 2, and what is called degree? Degree is what? Degree is what? It is the highest power of the variable in any algebraic expression, highest power. And we want to write quadratic polynomial whose degree is 2. So the degree of power, the highest power of variable must be 2. So the polynomial will get the form of this highest power. So highest power will come till here. The highest power will come till here for the quadratic polynomial. Highest power will come here. If we AND this whole expression, if we stop this whole algebraic expression till here, so this will give you the format of quadratic polynomial, because the highest degree will be 2, highest power will be 2. So the format will become ax square. This is x to power 0. So x to power 0 we can ignore, so we can directly write here ax. This is a plus, here this is a1x plus this is a2x square. And in mathematics, this quadratic polynomial got a very special format, because here a1 and a2 all are numbers, all are constant values. So we can write this equation in systematic order. Highest power will take the position first, so ax square. And for this a1x, we change this a1 from new value, new term, and that is called b. So this is ax square plus bx, and this is pure constant term. A0 is a number, A0 is a constant value, so it replaced by c. So this is the standard format of quadratic polynomial. Ax square plus bx plus c. There is what I have done here, my dear champion. I have replaced a2 from a. I have replaced here a1 from b, and I have replaced here a0 from c, and all are constant values. A, b, c, all are constant value, mathematical number, whether they might be in positive form or they may be in negative form also. They could be in negative form also, they could be in positive form also. So ax square plus bx plus c is the quadratic polynomial. This is the standard format of quadratic polynomial. Let me write here standard format. And what is the highest power, champion? The highest power is 2. Can you see here? This is the highest power. Now moving to next. If we talk about cubic polynomial, so my dear champion, for cubic polynomial, degree will come as 3. And degree is what? Degree is what, champion? I've already informed you. Degree is the highest power. Degree is the highest power of the variable in algebraic expression. So if we are writing here cubic polynomial, so the highest power will come here from this to this. And we have replaced a2 from a. So in this cubic polynomial, a3 will be replaced by a, a2 will be replaced by b, a1 will be replaced by c, and a0, pure constant value, will be replaced by d. So we got standard format for cubic polynomial. The standard format will become ax square plus bx, ax cube plus bx square plus cx plus d, and this is the highest power of x. That is called degree. And that's why this algebraic expression will become cubic polynomial. So linear polynomial, the highest power will be 1. The quadratic polynomial, the highest power will be 2. Cubic polynomial, the highest power will be 3. My dear champion, I want to give you one very important information about, very important. Always make sure, if you are observing any polynomial, if you are looking at any polynomial, any mathematical expression, algebraic expression, so don't decide very quickly that the written algebraic expression is polynomial. Don't decide quickly. Every algebraic expression, it is not necessary that every mathematical format of combination of variable and constant, I mean every algebraic expression will be polynomial. It is not necessary. It is not necessary. If I give you here one example, 2x to power minus 3 plus 4x plus 7 is equal to 0. Will it be polynomial? Is it the right format of polynomial? No, this is not polynomial. Despite of having relationship between constant and variable, it is not polynomial. Why? Because the power is the negative form. Power cannot be negative form. The power of variable should not be negative. If the power of variable is negative, that will not be polynomial. That is not polynomial. So to call any algebraic expression polynomial, being a polynomial, the power of variable must be positive. The power of variable must be positive, and the power of variable must be a whole number also. If the fraction number is there, power is fraction, the power of any variable is in fraction form, that will not be polynomial. So this is the property of polynomial. So in next slide I'll be teaching you property. I hope this is clear to you everyone. This is all about types of polynomial. Types of polynomial till here. Types of polynomial. So there are three types of, there are so many polynomials, but at your academic level, I mean in 10th level, at 10th level you will be studying 3 polynomial. And especially these 2 polynomial are very important, relevant for your examination point of view. Cubic and linear. Moving to next. I'm not talking about graphical representation. By the way, let me give you the information of graphical representation. When you draw the graph of any linear polynomial, it will give you a straight line. It will give you always straight line on graph. Straight line on graph. Straight line on graph. So linear polynomial always give you a straight line on graph. But if you draw quadratic polynomial on graph, it will give you parabolic graph. Parabolic graph. It gives you parabolic graph, champions. Please keep it in mind. Parabolic graph for quadratic polynomial, and linear polynomial will give you straight line. Linear means straight, man. Linear means a straight, champion. Linear means a straight. Moving to next. Okay. Now properties. So let's talk about here. Okay, can I erase it? Okay, I'm erasing it. Now moving to next. Properties of polynomial. Properties of polynomial. Important properties. So my dear champion, to call any mathematical expression as polynomial means to be a mathematical expression a polynomial, to get the identity of polynomial to any mathematical expression, the power of variable must be positive. Please make sure. If the power of variable is negative, that will not be polynomial. That will not be polynomial. That algebraic expression will not be polynomial. So power must be positive. Second point is the power of variable, the power of variable should be or must be a whole number. A whole number. If the power of variable is in fraction form, that will not be polynomial. That situation will be violating the rule of polynomial. That should be a whole number. that should be a whole number. So please, my dear champion, make sure to keep these 2 points to call any mathematical expression whether the given mathematical expression will be polynomial or not. So these 2 points are very important. For example, let's talk about few examples here. Examples. So let's talk about the given expressions are polynomial or not. Polynomial or not. So first, 2x square plus 4x minus 3 is equal to 0. Second is 4 by x plus 9x square minus 4 is equal to 0. Third is 7 under root x plus 9x cube plus 5 equals to 0. Fourth is 5x square plus 6 by x minus 3 is equal to 0. Fifth is 3x cube minus 4 by x square plus 3x plus 5 equals to 0. So let's talk about the given mathematical expressions are polynomial or not. So moving to first. So can you see here in first, this is the variable, this is the variable, and the power of variable is positive, which is following the first situation. And the power is also positive, so following first position, and the power of variable should be a whole number. Yes, here is power 1, here is power 1. So we can write this equation also as 6x. 4x plus 2x, 6x minus 3. So this is of course a polynomial. Why polynomial? Because the power is positive and the power is whole number also. Now moving to second. So second question is polynomial or not. So it will not be polynomial. Why? My dear champion, 4 by x. Here is 4 by x. Can you see here? This is 4 by x. So when you write 4 by x, so after taking x in numerator, the power is 1, so power will become negative, x to power minus 1. 4 by x means 4x to power minus 1 plus 9x square minus 4 is equal to 0, which is not polynomial. Why? Because the variable, the power of variable is negative, which is violating the rule, second rule. First rule, sorry, the power of variable must be positive. Here the power of variable is negative. So this is not polynomial. Moving to next, I am using different color of pens so that you may get visibility. Now second, third is 7 root x. Come on, 7 root x. My dear champion, if you remove the root, what will be the format? How will be the format? After removing the root in mathematics, you all know power 1 by 2 comes up. So we can modify this equation, 7x to power half. Yes, under root x means x to power half plus 9x cube plus 5 is equal to 0. My God, here x is power 3, which is in correct format, but this x to power half is violating the rule, and rule is the power of variable should be a whole number. This is not whole number. 1 by 2 is not whole number. 1 by 2 is fractional format, rational format. So this is not polynomial. So this is also not polynomial. Moving to next fourth question. Let me use green color for this. Okay, this is 5x square plus 6 by x. Come on, 6 by x. 6 by x. So if you take this x in numerator, this format will look like this, plus 6 x to power 1. X to power 1 will go in numerator and it will become x to power minus 1. Oh my God, x to power minus 1, which is violating the first rule. So that's why fourth equation will not be polynomial. Moving to fifth. Okay, now the fifth is 3x cube minus 4x square. Oh my God, minus 4 by x square. 4 by x square. So it can be written as 3x cube minus 4x to power minus 2. The power will become negative. 4x to power minus 2. 4x to power minus 2 plus 3x plus 5 is equal to 0. Can you see here? This is x to power minus 2. X to power minus 2, which is violating the rule of this first rule. The power of variable must be positive. So here the power of variable is negative. So this is violating the rule. It means that this will not be polynomial. I hope the properties of polynomial is clear to you. Moving to next. Now moving to zeros of polynomial. What is called zeros of polynomial? So my dear champion, if we write here one equation, let's say I'm giving you one equation, fx one polynomial fx is equal to 2x minus 3 is equal to 0. This is the equation, this is the polynomial, 2x minus 3 is equal to 0. Now, if I ask you, at which value of x, for which value of x, this whole equation will give you the result 0. If I ask you, what should we put here x? What should we put here at the place of x so that this whole equation will follow this? I mean, to make this whole equation equal to 0, what will be the value of x? What should be the value of x to make this whole equation is equal to 0? So my dear champion, if we write here 2x minus 3 is equal to 0, so 2x will become equal to 3, so x will become equal to 3 by 2. X is equal to 3 by 2. This is that value. If you put this value here in this equation, the whole equation will become 0. We can verify. Come on, verify it. So if we verify here by putting at the place of x, let's put here 3 by 2. So 2 into, at the place of x, again here will also be 3 by 2 minus 3. So this 2 cancel here. 3 oh my God, the result is 0. So at x equals to 3 by 2, this equation is giving you answer as 0. At x equals to 3 by 2, this equation is giving you result 0. It means that this x is equal to 3 by 2 is called 0 of the polynomial. So x equal to 3 by 2 is the 0. Sometimes we also call it root, and sometimes we also call it as solution. So x is equal to 3 by 2 is the 0, root or solution of the polynomial fx is equal to 2x minus 3, champion. So this is called the zeros. I hope you have understood. The value of variable which gives the result of that given polynomial 0, that value is called, those values are called polynomial. Now here in the example that I given to you, this is the example of x to power 1. What is the power of variable? The power of variable is 1. I mean, this is linear polynomial, and as this is the linear polynomial, that is the reason why you have only one root, only one solution. So for the degree decides, the highest power decides the number of roots, the number of polynomial. So my dear champion, if you are dealing with linear polynomial, and here I am writing here number of zeros. So my dear champion, linear polynomial, what is the degree? The degree is 1. For linear polynomial, degree is 1, and that is the reason why number of zeros will be only 1. Only one value will be there. Only to make this whole equation 0, only you can put 3 by 2. Except 3 by 2, other than 3 by 2, there will be no any number which will give you result 0. You can check it in maths, you can verify. Only 3 by 2 is the value which can give you the result of this whole equation is 0. There is no any other value apart from 3 by 2. So if degree is 1, so how many zeros will be there? Only 1 zeros will be there. Similarly, if we deal with quadratic equation, I mean quadratic polynomial, what is the degree in quadratic polynomial, champion? I have just taught you in previous slide. Quadratic polynomial, the degree is 2. The highest power of x is 2. And if the highest power of x is 2, how many zeros will be there? I have told you, degree decides the number of zeros. So if the quadratic polynomial is 0, I mean degree is 2, so there will be 2 zeros. 2 zeros will be there. How many solutions will be there? 2 solutions. How many zeros will be there? 2 zeros. How many roots will be there? 2 roots. All are same. Whether you say root, zeros or solution, all are same. Similarly, in cubic polynomial, my dear champion, in cubic polynomial, what is the degree? Yes, what is the degree? The degree is 3. The highest power of the variable is 3, and if degree is 3, degree decides the number of zeros. So how many zeros will be there, champion? 3 zeros will be there. And similarly for biquadratic, 5 zeros will be there. So this is very important thing, champions. This is very important thing. For linear polynomial, only one solutions will be there, only one zeros will be there. For quadratic, two zeros will be there. For cubic, three zeros will be there. Okay, now this question might be coming in your mind. You might be wondering, sir, to find the zeros of linear polynomial is very easy. By putting the equation equals to 0, we can find out the value of x, which is very easy and comfortable for us. Sir, how to find the zeros of quadratic polynomial? This is the important thing. And my dear champion, in this chapter polynomial, we will be talking about majorly about this. This is the important. Most of the question, I mean 95% chapter, 95% portion of the chapter polynomial is depend on this, related to this, based on this. So quadratic polynomial is very important. So we are going to deal with quadratic polynomial especially in this chapter, champion. So let's move ahead. Okay, so I have brought up a lot of questions here. So first you must understand the concepts, how to find the zeros of quadratic polynomial. Okay, so let's move to next. Okay, so same slide I'm using here. So this is quadratic polynomial. Okay, so the general format, the standard format I have already given you in the first slide. General form of quadratic polynomial is ax square bx plus c is equal to 0, and make sure this is the term which decides the identity. This is the terms which giving you information to call this equation as quadratic equation, quadratic polynomial, because x square is there. And why the x square is existing there? Because there will be some value of a is not 0. So my dear champion, for any quadratic polynomial, a can't be 0. A will not be equal to 0. So make sure if a will become 0, so the identity of x square will become vanished. If a will become 0, the identity of x square will be vanished. The x square will be permanently eliminated, and if x square will be eliminated, this equation will not remain quadratic polynomial at all. So to call this equation, to stay this equation as quadratic polynomial, a should be there, some value, whether negative or positive doesn't matter, but there should be some value of a. If a will become 0, this whole quadratic equation will not be quadratic equation at all. Right, so make sure please, this is very important thing. Okay, now general format, this is clear. How many zeros will be there? Number of zeros will be there. How many zeros? Degree decides. What is the degree? 2 is the degree. So how many zeros? 2 zeros will be there. And in mathematics, generally to assume the zeros, we generally use alpha and beta. To assume the zeros of any quadratic polynomial, we generally assume alpha and beta. So this is some new thing for you. I know you have just entered in class 10th. You must have studied about basics of polynomial in previous class also, 9th. So you must have a little bit, clarity on polynomial. So alpha and beta are the zeros of the polynomial. Okay. Now, if I give you the information about graphical representation, if we draw the graph of any quadratic polynomial, champion, graphical representation. So on graph, it will give you parabolic. So graphical representation is parabolic. When you draw any quadratic polynomial, sometime quadratic polynomial may be in this format, and sometime quadratic polynomial may be in this format. Open in downward direction, open in upward direction, depends on the nature of A. I'll be teaching you that when A is positive, A is negative, A positive, A negative decides upward and downward opening. Okay, so can you see here, this is x-axis, this is y-axis, this is x-axis, and this is y-axis. At how many points this equation, this parabola is intersecting this x? At 2 points. So 2 points. So these 2 points are the zeros basically. First 0 and the second 0. How many points? This A and B. So points A and B are the zeros of the given quadratic polynomial. Okay, so this decides the number of intersection. How many intersections are there? 2 intersections are there. So the number of intersection decides the number of zeros. Similarly here, at how many points this parabola is intersecting the x-axis? Again 2 points. So this is, and don't get confused, this is opening downward, this is opening upward. Don't get confused. This opening, the format of opening, the design of opening depends on nature of A. If A is in positive form, it will go A, B and C. I'll be teaching you everything later on, but just make sure to understand the basics first. Okay, so here A and B, this parabola is intersecting x at 2 points, and that 2 points are the zeros, right? I hope this is clear to you, right? So this is very important. Now moving to next topic, calculating, finding out the zeros of which polynomial, champions? Of quadratic polynomial. Okay, finding out the zeros of quadratic polynomial. So I'm taking one example here, one very simple example. Okay, so 2x square plus 7x plus 6 is equal to 0. Look at this is polynomial or not. First decide whether the given algebraic expression is polynomial or not, whether the given algebraic expression is following the rules of polynomial or not. So can you see here, x is power 2, the first term, the second term x to power 1, 1 is positive, 2 is positive, 1 is whole number, 2 is whole number. So this is absolutely polynomial, and the highest power is 2, so this will be quadratic polynomial. Now the most important, the biggest question arises here, how to find out the zeros. So let me give you the solution, how to find out the zeros stepwise, my dear champion. So let's talk about this. So my dear champion, in class 10th there is one more chapter separately, quadratic equation. There is one separate chapter, quadratic equation, in your textbook. So you will be studying about quadratic polynomial in depth and detail in that particular chapter. But here this is the beginning of quadratic, so I'm going to give you short glimpse. So we can find out the zero of this quadratic polynomial by 3 methods. There are 3 methods: middle term splitting method, completing square method, and of course quadratic formula method, which is also called Sridharacharya formula, right? So there are 3 methodology, there are 3 methods, 3 ways by using which we can find out the zeros of any quadratic polynomial. But here in this chapter I'm going to give you only one single method, that is middle term splitting method. So I'm going to use here by middle term splitting method. Yes, by middle term splitting method. And what is this? I know for some student it might be new, very new, so please focus here. So let's apply this method stepwise. So step number 1. So step number 1 says that multiply A and C. Come on, multiply A and C. What is A? The coefficient of x square is A. What is C? C is the pure constant. Can you see? The coefficient of x square is A, the coefficient of x is B, and the pure constant is C here. So multiply A and C. So if you multiply A and C, A is 2 here and C is 6, so the result will be 12. So this is first step. First step is done. Now step 2. Step 2 says that find out the factor pairs of A and C, A cross C. Find out factor pairs for A cross C. A cross C is 12. Now find out the factor pairs. Factor pairs means the pair of numbers which both the numbers can divide 12. So if we talk about here 12, so factor pair will be, the first pair automatically comes up 12 and 1. 12 can also divide 12 and 1 can also divide 12, and their product is also 12. So find out factor pairs in such a way, let me complete this statement, in such a way that their product must give result equal to A cross C. So you have to find out the factor pairs for A cross C, which is 12, in such a way that the pair that you have written, their product also should be 12. So 12 cross 1 will be the first, and the second we can write here, second will be 6 cross 6 comma 2. Don't write another bracket by reversing the digit. 6 comma 2 and 2 comma 6 both are same, so you don't write again that same bracket again. You don't need to write that 2 comma 6. 6 comma 2 and 2 comma 6 both are similar. So 2 comma 6. Can you please multiply 6 and 2? 6 and 2. 6 into 2 will be 12, and 6 can divide 12, and 2 can also divide 12. So this is the second step. Can we get one more pair? Is there any possibility? So the next will be, oh my God, 4 comma 3 will be also there. 4 comma 3. 4 can divide 12 and 3 can also divide 12, and the product of 4 and 3 is also 12. This is the second step. Now in these three, any one will be of your friend. Now find out the friend. Step 3. Step 3. Select, find or select your friend. You might be confusing, sir, friend, what you're talking about? So your friend is 7 here. Now in these three brackets, in these three factor pairs, you have to select any one which can give you the result equal to 7. What result? By adding the values. So in any of these three brackets, is there anyone whose product is 12? So all the if we pick any bracket here, the product is obviously 12. But we have to select the friend. This sign decides. So sign is plus. So their addition should be equal to 7. So in these three brackets, which bracket is relatable for this? Which is fulfilling our requirement? 4 and 3. Because 4 and 3, 4 cross 3 will give you 12. And according to this sign, we move forward. So 4 plus 3 will give you 7. Oh my God, and the middle term is 7. So 4 and 3 is your friend. 4 comma 3 is your friend. So now we can write this 7. We can split the 7 as 4 plus 3. We are splitting this middle value. So that is the reason why this is called middle term splitting method. So could you please proceed the solution? So this is 2x square. I'm using this as space champions. Okay, please focus here. So this is 2x square, and where is our friend? This 7 can be replaced by this 4, 3, and in addition 4 plus 3 x plus, that is 6 is equal to 0. My dear champion, it was the smaller number. That's why we can get the result comfortably directly. If the number may be bigger, this number could be bigger. So if the number is greater, bigger number, 100, 120, 500, so you need to follow the LCM. So sometime you also follow LCM rule. You will be required to find out the LCM also. But it was the smaller number, so we can directly get the brackets, factor pairs. So this is all about. Now can we please open the brackets? So 2x square plus 4 into x, 4x. 3 into 3x plus 6 is equal to 0. Now can we take common here in these two? So 2x will be common, so this will be x plus 2, and here can we take 3 as common, so this will be x plus 2. These two brackets must be similar. If these two brackets are not similar, it indicates you are making some mistakes, you are making some error in calculation. So make sure these two brackets after taking the common should be similar. Now in these two brackets only one is considered, and here 2x plus 3 will be written in single bracket. 2x plus 3 is equal to 0. After taking this as equal to 0, x will be equal to minus 2, and after writing this equal to 0, so x will be equal to minus 3 by 2. Oh my god, these two values of x are the zeros of this equation. If you want to verify whether by putting these two values, any one of these separately, first put minus 2 here, check out, the result will give you 0. Then put minus 3 by 2 in this equation, the result will be 0, and that is the reason why this is the zeros. I can verify you, so let's verify. So if we verify here, so let's verify x is equal to minus 2 in that equation. So x is equal to minus 2. Now put minus 2 here, so 2 into minus 2 whole square, and this is 7x, so 7 into minus 2, and here is plus 6. Now solve this. Minus 2 square will be 4, and 4 2 ja, this is 8, and this is 7 2 ja, 14, and plus minus minus, so this is minus 14 plus 6. Wow, plus 8 plus 6, plus 8 plus 6 will be 14. 14 minus 14, which is equal to 0. Hence prove that x equals to minus 2 is one of the zeros of this quadratic equation. X equals to minus 2 is one of the zeros of the given quadratic equation. My dear champions, my dear 10th students, please verify this value also at your home. If you are writing, if you are copying everything in your copy, please make sure to verify this value also. I hope this is clear to you. So this is called middle term splitting method. Okay, now the most important things comes up here. Let me please take a screenshot. If you want to take a screenshot of this, please take. I need to erase everything because I will be moving to the next topic. Please take a screenshot. Okay, now moving to next topic. Okay, relationship between, this is very important topic for your exam. Very important for your exam. Okay, and the topic name is relationship between coefficients and zeros of quadratic polynomial. This is the topic here. Very important topic as per your examination point of view. Very important topic. Okay, relationship between coefficients and the zeros of quadratic polynomial. What is the relationship between this? So let's take an example. So let me give you the formula first. So if we take a quadratic equation in this form, which is general format obviously, ax square plus bx plus c is equal to 0, and let assume alpha and beta are the zeros. We all know if we are dealing with quadratic polynomials, so this is obvious, there will be two zeros. So we are assuming that alpha and beta are the zeros. So the sum of zeros, if you do sum of zeros means alpha plus beta, if you do sum of zeros means alpha plus beta, this is equal to, my dear champion, minus b by a. Yes, my dear champion, if you do summation of the zeros of any quadratic polynomial, the result will be equivalent to the ratio of minus b by a. B is here coefficient of x and a. So we can write in words also. Let me write in words. So minus under bracket b is coefficient of x. So we can write here coefficient of x divided by coefficient of x square. A is the coefficient of x square. The first formula ready? This is the first formula. This is the relationship between champions, sum of zeros and coefficient. I hope the formula is clear to you. The sum of zeros means alpha plus beta, which we have assumed for this quadratic equation, is equal to minus b by a, and minus b, minus is the minus sign, and b is coefficient of x, clearly visible there, and a is the coefficient of x square. This is clear. Now the second formula comes up here is, second formula, champions, product of zeros means the multiplication of the zeros, alpha into beta. Come on, alpha into beta, product of zeros, alpha into beta will give you the result equivalent to c by a. Yes, c by a. Can we please write in words? So c is basically, this is pure constant term, c is the last term, no variable is there, only c is there, pure constant. So this is pure constant term, pure constant term, divided by a is the coefficient of x square. So a is the coefficient of x square. This is the topic that I have written there, relationship between coefficient and the zeros. So this is the, my dear champions, second formula. I hope this is clear to you. Let's verify, have patience. I will be verifying also whether this formula is making any sense or not. Let's verify. Please write it down, everyone, take a screenshot. Okay, so let's do the verification here. So okay, let's verify this formula, the power of this formula. So to verify this formula, let's take an example here. So I'm taking one example this. Can we take here x square plus 3x plus 4x minus 5 is equal to 0. This is here the quadratic equation. This is correct or not? Obviously this is correct because the power is 2, positive whole number. Here is also x to power 1 positive and 1 whole number. So this is completely quadratic polynomial. Okay, now find out the zeros first. So please do middle term splitting method. So 5 1 5, and this is subtraction sign. So 5 minus 1 will give you the middle value, which is 4 also. So we can apply middle term splitting method to find out the alpha and beta, because alpha and beta are the zeros. So let's find out x square plus 4 can be written as 5 minus 1, because 5 1 5 and 5 minus 1 will be, why I am taking minus, because this sign decides, the last sign decides whether this bracket will be written in positive or negative. This sign decides. Okay, so this is x square. Could you please open the bracket? X 1 x minus 5 is equal to 0. So here can we take here common x? So x can be taken as common. So x plus 5, this is x plus, oh, we are taking here, and this is minus 1. So this is x plus 5 is equal to 0. So we have two values. The first value will be x minus 5. By taking this bracket is equal to 0, and by taking this bracket x minus 1 is equal to 0. So x will be 1. We have two zeros. So now we have, initially we assumed alpha and beta because the zeros of this quadratic value was unknown. That's why we assumed. But here this is known. So basically alpha is minus 5. We can write alpha is minus 5, and here beta can be written as minus 1. Right, sorry, minus 1 is positive value. So this is 1. Now moving to the verification, sum of zeros must be equal to minus by VA. So could we please add here? So if we add here alpha plus beta, I'm verifying first alpha plus beta. So alpha is minus 5 plus 1, and that is giving you minus 4. Now alpha and beta, now find out here minus b by a. Minus b by a. So where is minus? Oh my God, this 4, this is called b. Here a is 1, here b is 4, here c is minus 5. Please make sure to write these things first. If you don't know a, b, c, you cannot use this formula, right? So clarity of a, b should be clear. So a is 1, b is 4, and c will be minus 5. Now if we put here minus b, b is 4, so this will be minus 4, and a is 1. So if we write here 1 in denominator, we don't need to write anything because a is 1 means 1. So alpha plus beta is minus 4, minus b by a is minus 4. It proves that alpha plus beta is equal to minus b by a, which is the first formula. Is it clear, everyone? Now moving to second. Let's check out the product. Let's do the product here. So alpha into beta. Alpha is minus 5 into this is 1. So the result is minus 5. Now alpha and beta is equal to C by A. Now could we please find out C by A? Where is C? C is minus 5. Wow. Minus 5 by A is 1. So minus 5 by 1 will be minus 5. Hence prove that the product of zeros alpha and beta will be equal to C by A. This is the result. I hope everything is clear to everyone. I hope everything is clear to everyone. I hope everything is clear to everyone. Yes, sorry, I got a call. Okay, is it clear to everyone? The sum of zeros, alpha plus beta is give you minus b by a. The result is equivalent to minus b by a, and which is equal to coefficient of x divided by coefficient of x square. Product of zeros is equal to c by a. C is the pure constant term and a is the coefficient of x square, and we have just proved it. A lot of questions are based on this. Okay, moving to next. My dear champions, listen. If quadratic polynomial is given to you, you can find out the zeros. Now if I ask you to do the reverse, if zeros are already given to you, will you be able to write the quadratic polynomial for that? Listen again. If quadratic polynomial is given to you, you guys can find out the zeros. Now just go through the statement of reversing this. If zeros are already given to you, could you please write down the quadratic polynomial for that if the zeros are given to you? So I'm going to give you the formula for that. My dear champion, is it clear to everyone? Everything is clear? Please take a screenshot. If you want to take a screenshot, please. Okay, I'll be using here this space. Okay, so how to find the quadratic polynomial, how to find the quadratic, how to write or how to find, we can write polynomial if the zeros are already given. If the zeros are already given, right? If the zeros are already given, so this is the topic. How to find the quadratic polynomial if the zeros are already given. So my dear champion, listen here. Do you know the general format of quadratic equation is ax square plus bx plus c is equal to 0. This is the general format. This is the standard format of quadratic equation, right? Okay, very good. If we divide this quadratic equation, both sides, dividing both sides by a. Dividing both sides by a. Let's divide this whole equation both sides by a. So this will be x square because a by a will be cancelled. It will look like b by a. It will become c by a. And if you divide 0 by a, so obviously the result will be 0. Dividing 0 by any number, that will be 0. Okay. Now my dear champion, can we please write this whole family b by a as minus b by a? Are you agree? Is there any problem? Sir, no problem. No problem. Sir, no problem. We can write x also as minus x. No difference between both. X means minus x. X means minus x. So similarly, b by a can also be written this. Now you might be thinking, sir, why you are doing this? I am doing this because we have very special format. We have very special format. If you remember, the sum of zeros means alpha plus beta for any quadratic polynomial is equal to minus b by a, right? And the product of zeros means alpha into beta is equal to c by a. So we can verify so this is minus b by a. Minus b by a can be replaced by this whole format, and c by a can be replaced by this. Wow, sir, this is magic. So it will become x square minus b by a minus b by a is equal to sum of zeros. So we can write here sum of zeros, and this x will remain in multiplication form, plus c by a is equal to product of zeros. So we can write here product of zeros equal to 0, and this formula is very, very magical formula. This formula will give you the quadratic polynomial, that particular quadratic polynomial whose roots are given to you, whose zeros are given to you. Let me give you a short example. So find out the quadratic polynomial. Find the quadratic polynomial whose I'm giving you a question, whose zeros are -4 and 3. Okay, find the quadratic polynomial whose zeros are -4 and 3. Come on, use this formula. Use this formula, champions. So x square x square minus, this minus sign will remain as it is. Now this is sum of zeros, and zeros are -4 and 3. So please add this -4 plus 3 into x, plus this plus sign will remain as it is according to the formula, and this is product of zeros. Now multiply this, -4 into 3 equal to 0. So what will be the result? X square -4 plus 3 under bracket, -4 plus 3 will be -1, and here is also negative value, -1, minus is there, so -1 plus minus will be plus, we don't need to write 1, so we can directly write x. -4 into 3, minus plus minus, plus minus, and this is also positive, so plus minus, so 4 3 are 12, -12 is equal to 0. This is the quadratic polynomial. If you go and find out the zeros of the quadratic polynomial, the result will appear like this. The result will come this -4. So this is the very important formula, very, 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 very important for exam, even for board exam also. If the roots are given to you, if the zeros are given to you, we can use this formula to find out the quadratic polynomial whose roots are given to you. I hope this is clear to you all. So my dear champion, I hope this session was very helpful for you all. If you are having any kind of doubt still after watching the video, if you are having any kind of doubt regarding polynomial, any question, any query, please write it down. And if you want single video for the questions practice for the polynomial, please do comment in the comment section. Thank you so much for coming. Stay blessed, listen to your parents, take care of yourself, and yes, keep watching this channel. Bye bye everyone.